All right, there's no better way to make you more familiar with the NMR spectrum by just sketch it, right, or use it often. All right, here's what I want you to do. So I'll do the first one for you. I'll have you do the rest. All right, this one I already gave you the signal and the chemical shift, so all the location are good now. The rest gonna be I just change this or draw the spin multiplicity, right? Expected spin multiplicity. Just draw on it. If you have my handout, just draw on the handout. All right. So let's say, for example, proton number one got two neighbors. So this one, the P gonna be a triplet. So I want you to draw a triplet on it like that. Okay. The height is 1 to 2 to 1 ratio, but it not necessary. But I mean, it's a triplet. Make it symmetrical. On number two, let's see. Number two, this is going to be quartet. So three neighbors, so it show up quartet. So number two is right here. We do a quartet. There we go. 1 to 3 to 1 ratio. And the last one, number three, is a singlet. No neighbor, singlet. Just put one peak right there, the singlet. That's it. That's what I want you to do. All right. Oh, check with the real spectrum. Take a look. Quartet, singlet, triplet. I'll go back one more time. Quartet, singlet, triplet. Yeah, quartet, singlet, triplet, just like that. All right. All right. I'll have you do on your own in here. All right. Start with carbon, hydrogen number one. So this one just by itself, no neighbor. Number one, or you have to guess a little which peak is it. Next to the oxygen, so the chemical shape about 3.7, 3.7 right here. This peak right here. All right. Singlet, put a singlet there. All right. 2 and 3 gonna be really close. This is proton on a benzene ring, so chemical shape about 7 to 8. Yeah, two peak right here, really close. And each one of them are doublet and doublet. So carbon 2 got one neighbor, carbon 3 got one neighbor on carbon 2. So double doublet. Carbon number 4. All right, so now move on to carbon number 4. Got one neighbor, but this neighbor is an aldehyde. All right, and aldehyde don't really split. Okay, so carbon 4, that's gonna be singlet, but where though? Well, chemical shift. So alpha position of the carbonyl and also alpha position of the benzene. Of the carbonyl 2.1, of the benzene 2.5. We'll get about 3. So right here, this guy right here, only one right here, singlet. And aldehyde, the last one, really distinct on a proton in a mass. So chemical shift 9 to 10, right there, singlet. All right, so make sure you know. So the following proton don't split: OH and H, carboxylic acid, and aldehyde. This is an aldehyde. Okay. All right, same drill, same drill. This one. All right, let's do this together on the next video. So this one I really want you to be able to do. So I give you a spec and a proton NMR spectrum, and you come up with a structure. And I have one more, which is like a full spectrum. Or could get proton, carbon NMR, IR later. All right.